Hello students, welcome to Saurav Sir's classes. This video is geometry part 18 and in this video we will be solving some of the problems based on geometry. Now in the first question we have prove that the diagonals of a convex quadrilateral are perpendicular if and only if the sum of the squares of one pair of opposite sides is equal to that of other. Now this is a quadrilateral that we have and we have renamed the sides as the following. Now let we have this angle AOB, it is greater than 90 degrees, that is, it is obtuse. So this would imply that angle DOC, this angle DOC, it would also be greater than 90 degrees. And angle BOC and angle AOD, they would be lesser than 90 degrees. Then by extension of Pythagoras theorem, we can say that a square, it is greater than p square plus r square. Next is c square, it is greater than s square plus q square. Now next is b square, it is less than r square plus q square, and d square, it is less than p square plus s square. So from these four we can say that a square plus c square, it is greater than p square plus q square plus r square plus s square, which is greater than b square plus d square, or this would imply that a square plus c square is greater than b square plus d square. Now this is a contradiction as it is given that, now this is a contradiction as it is given that a square plus c square is equals to b square plus d square. Hence we can say that angle AOB, it is not greater than 90 degrees. Similarly, in a similar way we will prove that angle AOB, it is not less than 90 degrees. Similarly we can show that angle AOB, it is not less than 90 degrees. Therefore angle AOB, it would be equals to 90 degrees. Now if AOB is 90 degrees, this implies that the diagonals are perpendicular. Diagonals are perpendicular. Now similarly, if we have the diagonals as perpendicular, then we would have angle AOB, it would be equals to 90 degrees. Therefore we will have a square is equals to p square plus r square. C square would be equals to s square plus q square. B square would be equals to r square plus q square, and d square would be equals to p square plus s square. So from here we can say a square plus c square is equals to b square plus d square. Therefore we can say that this diagonals are perpendicular if and only if the square of the opposite sides, they are equal. Hence it is proved. Now next, in the next question we have ABC is a triangle and the bisector of angle A, it meets BC at D. So we have this triangle ABC and this bisector of A, it meets BC at D, and here we have to show that AD, it is less than the geometric mean of AB and AC. So this is what we have to show. Now let us draw a circumcircle of triangle ABC. So if we draw a circumcircle of triangle ABC here, and now just extend D up to E, which is in the circumcircle. Now, so we have this. Now here this triangle, we will move to triangle A B D and this triangle A E C. Now here this angle ADB, this angle ADB, this is equals to angle, so angle ADB, it is equals to angle CDE, as they are opposite angles, and this angle BA, this angle BAE, if we take this sector, this angle BAE, this would be equals to angle BCE. So angle BAE is equals to angle BCE. So from here, from these two, we can say that this angle ABD, this angle ABD, it is equals to angle AEC, as see this angle is equals to this angle, and here we have this one is equals to this one. So we will have this angle ABD is equals to angle AEC. So in this triangle ABD and AEC, we have angle ABD is equals to angle AEC, and secondly this angle BAD, it would be equals to angle EAC. Therefore by AA symmetry, we can say that our triangle ABD, it is similar to triangle AEC, and because of this similarity, we can say that AD by AC, it is equals to AB by AE. So from here we can say that AB into AC, this is equals to AD into AE. Now this AD into AE, it is greater than AD square, as our AD is greater than AD. So since AE is greater than AD, therefore AD into AE, it is greater than AD square. So from here we can say that AD, it is less than square root of AB into AC, which is the geometric mean. Hence it is proved. Now in the next question we have given that in triangle ABC, the area is equals to half BC square units, and it is given that AD is median to BC. So we have to prove that angle ABC is equals to half of angle ADC. Now using sine rule, we know that area is equals to area of triangle, it is equals to half BC into sine A. So from here, now if this area half BC into sine A is equals to half BC, therefore we get sine A, it is equals to 1 or A is equals to angle A is equals to 90 degrees. So here we have this triangle A, B, C, where this AD, it is a median. So this AD is a median, and we are given that, so this would be BC. So we are given that area is equals to half BC. So from here we can say that sine A is equals to 1 or A is equals to 90 degrees. Now since AD, it is the median, since AD is median and angle A, it is equals to 90 degrees, therefore D, it is the midpoint of D, that is the midpoint of BC. It is the center of circumcircle of triangle ABC. So D, that is the midpoint of BC, is the center of circumcircle of A of this triangle ABC. So we can say that AD is equals to BD, it is equals to DC. So this AD is equals to BD, it is equals to DC. So from here we can say that angle ABC, this angle ABC, it is equals to, now what happening is, if we are making a circle here, so we can say that this angle ABC, at next angle is angle ADC. Now since D, it is the circumcenter, therefore angle ABC, it is will be equals to half of angle ADC, as the angle subtended by AC at circumference is equals to half of angle subtended by AC at the center. Subtended by AC at the center. So we have this ABC is equals to half of ADC, as this ADC, it is the angle subtended by AC at the center, and ABC, it is the angle subtended by AC at the circumference or circumcircle. So we have proved that angle ABC is equals to half of angle ADC. We have proved it. Now this is it for this video. In next video we will be solving some other questions. Thank you.